from the classification boundary. Okay, so hope you understand this. So if I take a projection, how do I find out the distance between two vectors? So the line, this is a line. If I have to find out the distance between this, then I have to project. So this point, if I project on this, okay, I will get this perpendicular distance, and this is a margin. So what is happening if I have different line like this or another line, let's say like this. So if I try to draw line which is like this, so this is also classifying, no? So all these plus points are to the this side and all these dots are to this side. So this is also classifying, but this is not the proper classification boundary. Understand? These two are not the proper classification boundary. The reason is SVM says that the margin should be maximum. And how do I find the margin? So we have to see all the close points which are very close to the boundary. And then we have to find out the average distance. Okay, like here, this point, they are close to this boundary. So as you see here, this plus sample is very close to this red boundary, whereas this is slightly away from this boundary. So this is not introducing properly the margin. So margin is not same for both the classes. So there is a chance that if anything goes wrong in this measurement of this sample may lie to other side of the boundary. So there is a threat of, you can say, misclassification. So there is a threat of misclassification. And that is the reason SVM says that we should maximize the margin as far as possible. So that's the concept of maximizing the margin. So I hope you have understood the concept of margin. The margin is basically, it is the closest distance, it is the distance between closest samples and the classification boundary that you choose. So how do we choose this classification boundary? And all of you know that we have to take some model equation for this classification boundary. And how do we do that? We do that by taking theta vector, so theta transpose x plus theta 0. So this is the equation. So my theta could be consisting of theta 1, theta 2, theta 3, and so on and so forth. So those many features, okay, those many weights, and x is also x1, x2, x3, something like that. Or this could be written as weight transpose into x plus bias. Okay, so we take the equation like this. So this equation could be simple like line equation, or this equation could be very complex like a circle or ellipse or something like that. That totally depends upon what are your features. Totally depends upon whether this is a simple line equation or whether this is a polynomial. Okay, so आपका क्लासिफिकेशन बाउंड्री लीनियर है या नॉन लीनियर है, उसके ये इक्वेशन पे मैटर करता है. सो राइट नाउ आई हैव टेकन अ वेरी सिंपल केस, लीनियर केस. ओके, तो आपको क्या करना है, बेसिकली व्हाट वी डू, we have to estimate this parameters theta or w, theta 0 and bias. Okay, given the data. So आपको डेटा दिया है, डेटा प्रॉपरली क्लासिफाई करने के लिए आपको क्या लाना है, वी हैव टू कम अप विद द प्रॉपर वेट्स सो दैट इट विल गिव यू अ क्लासिफिकेशन बाउंड्री जिससे आपके दोनों क्लासेस क्लियरली डिस्टिंक्टली क्लासिफाई हो ऑल दिस सैंपल्स. और कैसे क्लासिफाई होना चाहिए, दे शुड इंट्रोड्यूस, आई मीन your model should introduce sufficient margin, maximize the margin. और वो margin कितना होना चाहिए, क्या होना चाहिए, that we are going to see in the next slide. So मेरा classification boundary could be variety of this classification boundary. उसमें से ये जो black one है, if you see the black line, it is properly balanced. Okay, so ये जो closest sample points है, ये closest sample points, they are sufficiently away at sufficient margin from the given classification line. और ये होने के लिए आपको प्रॉपर मार्जिन इंट्रोड्यूस करना पड़ता है, एंड वो मार्जिन हम इसका डिस्टेंस निकाल के करते हैं. सो व्हाट इज द कंडीशन? The projection of this any closest sample. Try to understand. Projection. How do I find out the projection? How do I find the projection? So अगर मैंने, this is my line. Okay, suppose this is the line equation. Okay, इसका मैंने, suppose this is the sample x1. x1 के साथ डॉट प्रोडक्ट लिया. This dot product has to be 0 if this is properly perpendicular. I mean perpendicular distance. And then we can find out the distance. So if when we find out the product, dot product of these two, x1 is one vector, this is one vector, another vector. So if I find out the projection of this x1 on this, so I will get the distance. Okay, I will get the distance. And once I get this distance, I am ensuring that this distance must be some parameter rho. Okay. Now in SVM, we are going to say that this margin is kept as 1 unit. Okay. So this side it is plus 1, this is 1, this is minus 1. So this is class 1, this is class minus 1. Okay, you can see the margin here. So hope you are getting the concept of margin and this closest point. Now try to understand, ये line मेरा जो है black आना चाहिए या this आना चाहिए, this आना चाहिए, ये कौन decide कर रहा है? The margin is also decided. So this condition is also decided. So this condition is deciding whether to keep this black line or blue line or red line as a classifier boundary. Okay, that totally depends upon this condition, and that's why these are called as large margin classifiers. So with black line, the proper margin is getting introduced. Not only that, all the closest point to this are almost at equidistance from the line. So जितने सारे closest samples है, like this is x1, this is x2, let's say this is x3, this is x4. So all these sample points x1, x2, x3, x4, which are very close to the classification boundary, are in a way, they are supporting, they are actually defining the classification boundary. So classification boundary जो आपका decide हो रहा है, ये condition पे decide हो रहा है. और ये condition पे मतलब ये x1, x2, x3, x4 क्या है? So all these are closest sample points, and these closest sample points are called as support vectors. Now why they are called as vectors? Because x1, x2, x3 could be vectors. Okay. Now we are finding out the dot product. We are finding out the distance between these two. So in a way, अगर मेरे ये closest point change हो गए, मेरे support vectors change हो गए, तो मेरा boundary change होने वाला है. And that is why it is said like in SVM, support vectors basically define the boundary. And that's why they are called as support vector machines. So hope you have understood the concept of support vector. Support vector मतलब क्या है? ये ज़्यादा कुछ different चीज़ नहीं है. So I have samples. Okay, let me erase all these things. I have all these samples. Sample में से जो कुछ samples है which are very close to the boundary, like यहाँ पे plus दिखा है, यहाँ पे this dot, two dots are very close. Okay, then this also. They are closest points, and these closest points, कैसे closest points है? Such that the margin is +1 and -1. So margin is properly maintained. Such sample points, such data points are called as support vectors. So मेरा जो data है x and y के format में दिया जो, so all these are data. Out of this, some of the x data points are actually very close to the classification boundary. These are actually called as support vectors. They define the boundary, and that's why this is called as support vector machines. I hope the concept of support vector is clear. Yes, all of you. Can you give the quick feedback whether you have understood this?
Sir, so the
Yes, sir.
margin value for all these support vectors will be 1.
Pardon, pardon.
Sir, the margin value for these support vectors will be 1 or
Of
something
course,
else.
this is what expected condition is.
Okay,
Okay,
sir.
so we are going to put it in the mathematical form.